Hi everyone, let's do another problem on chi-squared test for independence, just to get some more practice and walking through it with you. So, just a reminder, our critical values here, this table, we will use that today during this example. So, the table here talks about the number of people intended to vote in the next election. So it's comparing the age of the voter versus the party that they are voting for. It says for a 10% significance level, what is the critical value, which is chi-squared crit. So for part A, if I'm at a 10% significance level, that means that alpha is 0.1, and our chi-squared crit is found by using our degrees of freedom with our significance level. So our degrees of freedom, remember, for test for independence, the chi-squared test for independence is your row minus 1 times your column minus 1. Well, in this case, I have 2 rows and I have 3 columns. So that means I'm doing 2 minus 1 times 3 minus 1. Well, 2 minus 1 is 1, 3 minus 1 is 2, so 1 times 2 means my degrees of freedom is 2. So I have a 10% significance level and a degrees of freedom of 2. So degrees of freedom of 2 at 10% gives me a critical value of 4.61. So our chi-squared crit is equal to 4.61. That is the answer to part A. Now part B says, conduct a chi-squared test for independence at a 10% level to determine whether there is an association between the age of the voter and the party they wish to vote for. So for part B, we're going to go through all of our steps. Well, step 1 is to identify our H sub 0 and H sub 1. So that means that the age and party are independent, and H sub 1 would be that age and party are dependent. So remember, H sub 0 is always that they are independent. H sub 1 is that they are dependent. Okay, we already have identified our significance level and we have our crit already figured out. So now we need to make our observed and our expected tables so that we can then run chi-squared on our calculator. So this right here, this table, this is our observed. So that matrix right there would be our observed. What we need to do is find our expected. And in order to do that, we need to have, I'm going to erase this stuff here. We need to have our sums so that we can do that. So when I add 85, 95, and 131, I get a sum of 311. When I add my party B, I get a sum of 538. And that gives me a total of 849 people that have been identified. And now that when I add my column of 18 to 35, I have 253. 36 to 59 is 292 people. And then 60 plus is 304 people. And remember that that's important because that's how we're going to find our expected frequencies. So let's make a table here. And so this is A and B, and this is our 18 to 35, our 36 to 59, and our 60 plus. So remember, to find that, we need to do our total of A times our total of the 18 to 35, and then divide it by our overall total. So we're going to take, if we scroll back up here, we're going to take 311 times 253 divided by 849. And we are going, whoops, undo that, sorry about that. So when we do that, we get 92.68. And then when I take 311 times 291 divided by 849, I get 106.96. And then as we continue that, I'm just going to fill this chart in here. You continue to do that, and these are the values that you are going to get. So 160.32, 185.04, and 192.41. So that table right there is my expected. So now we need to go to our calculator and we need to enter those matrices into our calculator. So let's take a look at our observed. So go to your calculator. We're going to go second x to the negative 1. And then we're going to edit A first. So scroll over to edit and hit enter. Remember, this is a 2 rows by 3 columns. So we're going to go 2, enter, 3, enter. And then we have 85, 95, 131, 168, 197, 173. Second mode will get you out of that. And then go second x to the negative 1 again. Scroll over to edit, but we need to scroll down to matrix B. Hit enter. It's again a 2 by 3. So 2, enter, 3, enter. And then we need to enter in our expected values, which is 92.68, 106.96, 111.36, 160.32, 185.04, and 192.41. And then once you enter that, second mode to get out of it. And now we need to run our chi-squared test. So we're going to go stat, scroll over to test, scroll all the way down to the chi-squared test, not the GOF, just this chi-squared test. Our observed is matrix A, expected is matrix B, and you're going to hit calculate. And we find chi-squared is, chi-squared calc is 8.58, and our p-value is 0.0137. Okay, so let's use that information. Remember, we are going to reject h sub 0 if chi-squared calc is greater than chi-squared crit, or if p is less than alpha. Okay, so our chi-squared calc was 8.58. Our critical value, if you recall, was 4.61, and that is greater than, 8.58 is greater than 4.61. And then if we want to check it further, our p was 0.0137. Our alpha was 0.1, because it asked for 10%, and that is less than. So both of those are true. Chi-squared calc is greater than chi-squared crit, and p is less than alpha. So because both of those are true, then we are going to say that we are going to reject h sub 0. And we can conclude that age and the party that you're going to vote for are, since we're rejecting h sub 0, that means we are accepting h sub 1, which means the party and the age are dependent of each other.